Hey guys, and welcome to Future Proof Engineering, how Visma learned to love continuous development. It's our latest webinar. And today we're featuring Mili Orucevic, who's the Chief Software Quality Engineer over at Visma. I'm Jared, I'm Content Manager at Unleash. And before we get started, some quick housekeeping. A lot of you are going to be joining from multiple platforms today, and in each platform there is a comment box. If you have any questions, you have anything to say while you're watching the presentation, just type it in the comment box. We'll see it, and we'll make sure to share it with Mili. And this is true throughout the presentation. If we get a ton of questions today and we don't get to your question, we will answer at some point. So just ask away and have fun. But let's practice. Real quick, inside the comment box right now, type in which country you're joining us from today. Okay, cool. So you're not going to see a lot of my face today. Today is going to be mostly about Mili, and Mili's going to be talking about continuous development and really, continuous adaptation as kind of a ticket into future-proofing an organization. So Mili will be joining us right about now. Cool. Hey, Mili.
Hello. You can hear me okay?
Hey, quick agenda is Mili's going to give a presentation. It's going to be, 30, 45 minutes-ish, right? Yeah. Cool. Yeah. And then afterwards, it's going to be a Q&A. I'll come back in and I'll be fielding questions from you guys. For Mili, stay as long as you like. We'll get to as many questions as we can. And again, type them as they occur to you in the chat. But that's it for me. Mili, you're good to go. See you in a bit.
Thank you very much. Let me just share my screen. I think you should be seeing my presentation right about now. So thank you and welcome for joining this. My name is Mili. As mentioned, I am the Chief Software Quality Engineer in Visma, and I work in an enablement team that is basically assisting and enabling all the other Visma companies and teams how to utilize modern software engineering. And that is what we will be talking about today. So we'll go a bit into why we changed as we did and what led us to this change, what kind of metrics we are using to drive our engineering performance, and actually how we did this on scale. And at the end, of course, I want to leave you with something that you can go back to your workplace or just for your learning if you're here just to learn how others are doing things, where you should start if you want to start on a similar journey as we have been. So to start with, on the why we did actually this change, and I think Peter Diamandis here captured it really well. The world around us, it's not only changing fast, it's really accelerating. So the world is everything that is happening around us. It's not happening like a step by step. It feels sometimes like it's happening like 10 steps at a time. And just to give you some examples, if we just look at, for instance, the computing power and the cost of computing power of the last 10, 20 years, it's 100 times cheaper today, for instance, than it was only 10 years ago. So the price of technology is actually going down. And this means that the technology is becoming available to everyone all around the world. And this also means that as the technology is increasingly democratized, as is the knowledge of using that technology. So this means that anyone from their boys' rooms or girls' rooms or from their garages, they can actually just start typing away, creating cool services, as we have seen being developed over the years, and especially the last 5 to 10 years. And previously, if you wanted to create a service or an application at scale, you needed to invest a lot of money upfront. So you needed to buy server spaces, racks, a lot of hardware, and then you could basically reach out to the world. Today, it's just a click of a button. And if you want to learn how to use something today, you can basically do it just by watching some tutorials, and everything is available for you online. So the technology and knowledge is increasingly democratized, both for us in, for instance, Visma, and it's also true for all of our competitors, but it's also true for a lot about the bad actors out there, such as criminals, for instance. And the criminals, of course, they utilize this as well as we do in a good way, but they are just doing it in a bad way. And if you just think about what cybercrime and cyber attacks has been mentioned in the media over the last 5 years even, Today, you don't need to explain to anyone what the cyber attack is. When the cyber attacks is coming up or some breaches in the news, everyone sort of knows what is being talked about. Like if you did that like 5 or 10 years ago, even you would first need to have a segment about explaining what a cyber crime is, what is a cyber attack. But basically today it's a well-known thing. And this is, of course, something that we need to guard us for. So a lot of investment needs to be done with this if you are going to develop software in a modern way and utilize sort of the modern software engineering practices and the platforms that are available for you today. So we need to be aware of these disruptors, as the bad actors can, of course, disrupt your services as well. Another thing that has changed, of course, is the user expectations, because everyone has been used to how like Facebook or Google, all these big companies are developing software, and that also needs to replicate sort of how everyone else is developing software. Of course, not everyone has the budget of Facebook or Google to sort of replicate everything they do, but we need to be aware of what the customers and the users are expecting from us. For instance, some customers say like, if a company does not adapt to my changing needs or expectations, it just feels like they don't care. So here, the sort of key is that you need to listen to your customers. You need to check with them really often, and that is something that we wanted to do as well. So basically, to sum it up, the changes that are around us basically causing disruptions all over the place, and disruption today is more likely than ever. And we realized this quite early on in Visma. Just some years ago, we understood that, okay, if we just continue to do things as we have done it all the way, we will probably not succeed. And we have these outdated technologies. They were good back then in the time, but we really need to sort of change how we are working. And this is one of the sort of things that kicked in, that we realized that we definitely needed to change. And this is just one sort of a small example in a field where you can imagine, and it's quite clear like that changes are happening every single year, every single season in the Formula One. And I guess many of you probably listening today have watched Drive to Survive on Netflix and seen how these developments are happening. And this is also something that really needs to be happening in our field as well, in the software engineering field. So we realized that we need to change. And of course, if you ask who wants change, everyone agrees, like, yes, let's do it. Sounds good. But when you ask, like, okay, of you, who wants to actually change? Like, yeah, no one wants to change. They just want to keep doing things that they have always been doing. But it's really interesting, like, why this is like that. Like, what is actually a change? And if you just look at the definitions of a change, it basically means that you want to make something different. You want to alter or modify something, or you want to replace something with something newer or something better, or basically a process or an act of something becoming different. And if you look at sort of the psychology of people in general, people actually don't want to actually change from their known environment where something is safe. Like, we have always been doing this. It works. Like, we are safe here. Like, why do we actually want to change? Why do we want to go from this cozy bubble that we are in into like an unknown place, unknown bubble? We have no idea what is actually happening. And this can be also, of course, traced back to other industries as well. Like, if we just look into like biology, most changes or mutations are bad for you. We have like recently been through a pandemic, and we know all about these mutations right now. And of course, if you go to your doctor and he says like, yeah, we find some mutations on your cells or something like that, yeah, you're not sort of shouting and hooray for that. And in neuroscience, for instance, back to this talk between Maim and Yuval Harari, why we are afraid of change, it's basically that even though our brains are geared toward learning new things and incorporating new experiences, we will always take sort of the path of least resistance when it comes to change. So if we don't need to change, we will definitely not do that. And this is also something that is reflected in the startups. Around 90% of the startups fail, basically, due to this. Not because they have bad products or because they are not good at advertising, but it's just because people are not actually ready for it. And you can also like think about it from like, if you just remember like when iPhone was launched as a first smartphone. Before iPhone, there was like a number of similar phones, but people were not ready for the change basically back then. So now that you sort of have this background of why change is important, I will also dive into like how we did change. But before I do that, I just want to share with you like what Visma is, because I think this will be quite interesting and important for you to understand, so you know why we did the change as we have done it. And I think most of you have basically seen Visma, or like for you perhaps outside the Nordics, you know about the Jumbo Visma team, bicycle team in Tour de France and other cycling events, or some skating events as well. But we are basically a software company, or better to say, we are a collection of software companies, where all the different companies are basically entrepreneurial companies who have their sort of own startup mentality, personality, leadership style, and highly autonomous when it comes to how you want to run your business. But what is common for everyone in Visma and being part of Visma is that our vision is basically that we want to shape the future of society through technology. Basically, a lot of the automate or complex processes and automate them and simplify them for sort of our users. And that is what we actually want to do. So we are approximately 15,000 people. We are also growing quite a lot through acquisitions. And a lot of companies who have joined Visma, like last year, around 40 companies joined. The year before that, 40 and other companies joined. So we are growing quite a lot by acquisition and organically as well. And all of these companies sort of are sort of highly autonomous when it comes to how they work, how they do things. So very, very little is actually mandated through this. So back in 2015, our sort of big change started. We went back to the drawing board and started to think of like, okay, how can we change this trend, like where we are today? It doesn't work. We know that this won't scale. So where do we actually start? So what we took a look at is basically, okay, how are we organized today? What are we doing today? Do we have any bottlenecks? So our sort of journey started in that end. So we started to look into things like DevOps and how are we organized? What kind of mentality do we have? And if I just take sort of my career as an example here, and there are a number of similar examples, when I actually started working in the software industry back in 2009 full time, I was part of a test team. So we were actually not only divided by a wall, like in this illustration here, where the developers were on one side, they were creating products. When everything was finished, they threw it over the wall to the test team. The test team tested, found different issues, different bugs, threw it back again over the wall. So the communication was not very great. And this, of course, led to a lot of frustration and like going back and forward. And at some point, the developers realized like, okay, but these guys that are part of the testing, they're actually finding quite interesting issues. Like, if I knew this like a couple of weeks earlier, we could have fixed it and avoided this long tail communication that we had. So what we decided to do at some point is basically to tear down the wall and say, like, you know what, like, let's bring all the testers and all the developers. They should not be part of like separate teams. They should be part of one team. So basically, that was sort of one of the first thing that happened, which also happened sort of approximately at the same time that we did this. But then we also realized that now that we were organized as like one team, the developers and the testers, there were actually some other roles that were organized outside the team, like for instance, the operation role. And here, of course, the incentives were different. Like the developers and testers, they developed something, they tested it, and then they threw it over the wall. Like here, deploy this in pre-production, and then later in production if everything goes well. And of course, things didn't go well because, like, yeah, you didn't care about how this behaved in production because that was not part of your responsibility. You were responsible for developing this and testing it, and it usually worked in our environments. But when the operation team got it, deployed it, nothing worked, and then it was like a blame game back and forward. And this could also take weeks before this sort of were fixed and went back and forwards. So we realized that this won't scale. And also when things were to be deployed in this pre-production and production environments, it also meant that all the other integrating teams should get together, check if everything works. If everything worked, then of course you moved forward. If it didn't, then back to the drawing board. And if you imagine that you have like, let's say, 15 or 20 integrations, and you need to be part of these 15 or 20 different system tests that was called back then, when would you actually get the time to actually develop something new for your own service? So it didn't scale at all for us. So we, of course, decided to break down this wall as well and put everyone from sort of operations within the same team. And basically what this meant was that we formed something that we ended up calling the service delivery teams, which are highly cross-functional and autonomous teams. So they are the ones that are fully responsible and have the full and exclusive ownership of the service that they are creating, end-to-end responsibility, basically. They plan it, they make it, they ship it, take care of it, like they got this, basically. And because of this, of course, they also get all the authority and the trust that they need. Because like who else knows better than the team actually creating the software and making sure that it works for the customers as well. So they are fully sort of in charge for this. And this basically means that this is how our teams look at themselves now. They are sort of like, as mentioned, highly autonomous. They have all great core areas where they are really good at. Some are really good at developing something, some testing, someone is really good at the infrastructure and operations part. But together as a whole, it's really important to emphasize that they together are responsible for that this works. So it's not only one person show, it's sort of the whole team approach that we have here. So after we have sort of done this, we also realized that, we have sort of course, and just to make sure that this is sort of understood, that all of these core principles that we are talking about here are sort of done in parallel. So it's not like we finish this and then we move to another step. So a lot of these things were done in parallel. The next things that we also want to look into is basically how can we minimize the gap between us who are making the software and the people that are actually using the software, the users and the customers. And because we need to thrive in this accelerating world. And then this was continuous delivery. And back in 2015, we deployed around 6 times a year on average across all different teams. But now lately in 2022, we have actually around 29 releases per month in average. And for the entire 2022, we released over 37,000 times in production. These around 100 teams that are working this way. And I could, of course, dive into continuous delivery in many different aspects, what we did, but the basics there were that we wanted to get changes out quickly. We needed to change the way that we worked, not pile up a lot of different changes, pack them together and deploy them, but rather think about, like, you have done something, you need to push it to your delivery pipeline, which should go all the way to production. Sometimes, of course, some teams have this manual step of acknowledging this before in production, but many teams, as soon as it's part of the main release branch or main branch, it's basically being trajected towards production. And we want to work in smaller chunks, much more iterative, get feedback quickly from the customers, deploy changes during daytime. The zero downtime deployments is sort of a must, and automate where we can automate. And this also enables us to experiment a lot using feature toggles, for instance. And one thing that I can dive a bit into with the interest of time here is basically how we do continuous testing within this continuous delivery workflow. And I think most of you have also seen this never-ending loop where it's been sort of presented in many places where they talk about continuous integration, continuous delivery, and continuous deployment. But one thing that we don't do here is basically that we do not have an own test phase as it's illustrated here. In Visma, when we are actually developing software, we are thinking about testing all over the place. So we are testing and thinking about testability and testing, as soon as we start planning something, we think about it. And even when it's sort of deployed in production, testing doesn't stop there. We still can extract a lot of information about change being out in production through monitoring, through different logs, and we can learn from it and, of course, feed it back into how we are doing things. And if we look at how testing changed for us, we, of course, need to shift a bit left, shift more to the right as well. And looking into sort of shifting left, of course, that means that we need to think a bit more critically and ask some questions early on between different like roles within the team. We can also not always assume that whoever has written like a user story, that we understand it the same way as they do, whoever wrote it. So we need to sort of ask some questions, and also bring in sort of different roles to discuss, okay, what does this change mean? Like how easy can I test this, or how easy is this actually to deploy, or how easy is this to change? Will it affect anything else? Will the users use it at all? Like, we need to think about all of these things really early on. When it comes to the technical parts, of course, like, we are thinking about how to automate things. Like, can we automate this as a small check that will be part of our CI/CD pipelines, or is this sort of one-time off thing that we can just check now, and if it works, yeah, we don't care about it. We have sort of a larger regression test that will actually check this later on. So, and of course, where it makes sense, try to sort of push down these automated tests. If you think about the test automation pyramid, and I know there is a huge discussions about these pyramids in the industry, and especially in the software testing communities, but we are not religiously sort of using them. We are just using them as a guidelines to actually drive our tests going forward. So you should, of course, not have a lot of UI tests, but and more sort of tests as far down as you go in this pyramid. And in some cases, this pyramid looks like a diamond as well, because teams that are working on microservices, they prefer to write more integration tests rather than sort of isolated unit tests. But these are sort of some of the things that we are looking into when we are shifting left. And also to mention this statical code analysis, quick feedback, of course, from the tests, the unit tests that are there, and also think about security really early on in this phase. But this doesn't sort of it's not enough, basically, because we also need to think about when we shift right, when we deploy something in production, what does that mean? Because suddenly we have a team that is responsible for everything. So we can utilize a lot of things in production as well. We are not there that we are sort of testing everything in production, as some companies are doing, or like Facebook, for instance, they are testing a lot in production. But we do test some things in production, of course, like run some smoke tests, heartbeats. We are experimenting a lot in production. Basically, when something is deployed to production, we can hide it behind the feature toggle, and then we can use that to actually just give it to a portion of customers or users, or just use it internally, see how it works. And then, of course, if everything works okay, we can sort of release it to everyone else. And then we're also thinking about reliability scenarios, because we know that things will go wrong in production, like we will have incident at some point. So in some cases, we are also sort of trying to imitate these issues before they actually happen, as part of something that we call the business continuity plan. So we know that, for instance, like the region might go down in one of the public cloud providers. So we try to sort of mimic that behavior and see like how our services will behave. Or we take down some different parts of the service that the service is depending on, seeing if we have some single point of failure and stuff like that. And then, of course, performance engineering is also really important. And this goes a bit back to the monitoring as well, because if you're going to deliver continuously many times a day, you also need to think about like what are the monitoring that you have there, and you cannot sort of performance test everything. So performance testing is a small part, but basically we need to look at it as a performance engineering. So our continuous testing strategy is quick feedback for everything. We automate where we can and where it makes sense, and don't rely too much on manual processes and steps. Then we also utilize this test automation pyramid or diamond in some cases. And one thing that is also important to mention, that is also what we try to avoid manual regression tests. And this doesn't mean manual testing is not there. It basically means that we don't want to do manual regression testing. The things that are done over and over again, those we don't want to do manually. Those can be easily automated and should be automated. So we can spend more time on actually trying out these borderline scenarios and play around with new technologies and other things. And then, of course, non-functional testing is being treated equally as important as functional testing. This was something that always came as an aftermath back like 10, 15 years ago. But today, I think it's if not more important, equally important as functional testing, because no one cares about how your product or how many features you have if it's not secure, if it doesn't have good performance, and if it's not reliable. Then it doesn't matter that you have the awesome feature set that you have out there if those three things doesn't work. And of course, in the end, the whole team approach, it's not only for testing, but in testing, it means, of course, that there is no one tester or test team or whatever that can actually test all of these things, like unit tests and API tests and performance tests, security tests, reliability tests, etc. This needs to be done as a team sort of effort and the whole team approach. That was a bit on the continuous. So now that we have sort of organized our teams, we want to deliver in smaller chunks continuously, frequently to production. We also want to utilize ourselves from the public cloud, basically. And this is really important for us because if we want to utilize continuous delivery capabilities, it's really important that we can be self-service and we can sort of spin up whatever environment that we need when we need it, like scale out, scale in when it's needed. So public cloud is not only sort of to use the latest technology, but also the self-service sort of level that they have. It's really important for us to utilize this, because then every team owning their own subscriptions in Amazon or in Azure or these projects in GCP, they can basically, whenever they need something, they can just provision it as part of their delivery pipeline, do what they need to do, then deprovision it, put it into next environment, promote it, deploy it in production, scale out, whatever is needed can be done as via code, infrastructure as code. And this is, of course, also continuously evolved. So we always get sort of the latest and greatest that technology can offer. And their sort of investment in security in these public cloud platforms are like really huge. So in Visma, we are utilizing AWS, Azure, and GCP where we can. There are, of course, some exceptions to it, but they are basically very rare. So when we have gone through all of this, we figure out that, you know what, this is actually the way, this is how we want to develop software in Visma, and this is sort of how we should evangelize for everyone in Visma to develop software. And so this is actually the way that Visma is developing, delivering, and operating cloud services. And it describes like how you should be organized, some technical requirements that all teams should have. I just sort of covered really small parts of this continuous testing part, and basically best practices for successful cloud services. But if you want to sort of scale this up to the entire organization, and remember, like we are 40,000 people, everyone is highly autonomous, independent. We also needed to create some kind of self-service, as sort of we were funded in from the public cloud vendors. And what we have done is basically that we have created a set of self-service gap analysis, you might call them. We call them in some cases assessment, in other plans, is how actually you can create a successful software as a service. So we have like a self-service analysis for how you're doing your public cloud architecture, how you are doing continuous delivery, how you manage your technical depth, or how you are creating your software architecture, API development, design, and management, software testing, if you want to sort of deep dive into that area as well, even though lots of parts of it is also part of the continuous delivery. The business continuity plans and the performance management plans, all of them are sort of part of this program that we have to build actually modern software services. And everything here is highly sort of self-serviced. It's also concerned about security, about cost as well. And for security, we even have an own program for that, how to build actually secure services in 2023 and onwards. So once we have sort of created this framework for the teams and we knew that this was sort of the right way to go, but we also wanted to make sure that we have some data backing this up. So it shouldn't be sort of based upon like a gut feeling that, yes, we this is cool, this is nice, we think this is the way to go. How can we actually make sure that we have some numbers? So how can we actually measure our software delivery and operational performance going forward? So we started a bit simple back in 2015. We had a huge spreadsheet of different metrics that we could look into, what we could measure, what we cannot measure. And also keep in mind that Visma is sort of highly autonomous, as I mentioned several times. We don't have like one tech stack or one way of working. There might be like every technology that you can imagine. We probably have a team that is using it in combination with another technology that you imagine. So here we also need to think about, okay, how can we get all of these to work together and perhaps report on the same things? So what we wanted to look into was, okay, how many times you deploy to production, that should be like easy. Let's just count that, like 1 time, 2 times, 3 times, etc. That's the easiest one that we can start with. Then we also wanted to learn a bit more about, because we had some teams that were, when they deployed, there was always like a patch ready to be deployed right after it, because they were deploying 600 changes at the same time, and you knew that something would blow up at some point, because it was impossible to test all these different changes in production, especially when you were not owning production. So we also wanted to know that, okay, if we start deploying more often, does that mean that we will also have a lot more change failures? And that's something that we wanted to measure. And the last thing that we knew that everyone could basically measure is that once you start your deployment to production and once you end it, there should be a time gap between there. And we want to know that. And that's where we started, basically, really simple. But then in 2018, this great book came out, Accelerate. And I think probably most of you are very familiar with it. I can sort of encourage you to read it if you haven't. Where around 30,000 people have been surveyed around over 6 years in that period. And they were being asked, like, how do you develop software? Like, how does your team do this? Are you good, bad at it? Or like, how does your revenues look like? If you deploy often, does that also mean that your revenue is going up or down? So there was a lot of questions that were being asked throughout the years, and they sort of did this statistical analysis and see if there were some correlations between these different metrics. And they figured out that there were some metrics that you can sort of use in order to actually perceive and see if you will meet or basically exceed your organizational goals. So if you were doing really well on these SDOP metrics, or software delivery operational performance metrics, you could actually outperform others. And a couple of years later, of course, McKinsey & Company came also out with this survey where they have 13 different capabilities, or construct of these 13 different capabilities, where they found also that companies that did really well on this developer velocity index, they were 5 times generating revenue 5 times more than those who were actually not in the top quartile percentage. So this was also something that sort of backed up some of our sort of hunches or gut feelings back then, because we did not have the vast amount of data that we have today. So basically, this meant that these are the 5 metrics from the SDOP that have been studied across multiple companies, across multiple regions in the world. Basically, the delivery lead time, deployment frequency, change failure rate, time to restore, and availability and reliability. And then we decided, like, we already are measuring like 2 or 3 out of these. Let's try to expand this to everything. So this is what we are sort of measuring in Visma. And how we are doing that is basically, you probably won't believe it, but through Jira, of all things. Because Jira is basically one common denominator for all teams in Visma. They can use different tech stacks, but everyone is using Jira as sort of their bug tracking tool. So then we said, like, as part of your delivery to production, you should actually create like a query to Jira where you should register some metrics or some numbers. And then every time you deploy, we are registering, like, okay, which team is deploying? Is it successful or not after the deployment is done? How many changes do you have? And how much time did it take for you to complete these 3 changes, for instance, in this example? And this is done automatically. So this is not something that the teams care about. Like they set it up once and then they have it forever. The second thing that you also need to track is basically if you have any manual changes. So if it doesn't work to deploy without any downtime, you manually need to register a manual change. And then, of course, register if you have some unavailability or not. And the last thing that they register is also the incident incidents. So whenever an incident, we know when it started, we know when it ended, and then we manually register it. And basically, these three things are the ones that are leading into these different metrics, which we are basically continuously using for our teams. And this is measured continuously. So if you remember sort of the way of working, like this is the way, all of the teams that are working that way, they have like an own, what we call a service page, basically general information about the teams, about the services, what they're doing. And then in an automated way, we are tracking a lot of these metrics from different places, from Jira, from Confluence, from different tools that we have around. And this is automatically reported into something that we call the Visma index. So this is an automated way of tracking these different findings. When you do a gap analysis or an assessment, if there are some deviations, you don't have the capabilities to do zero downtime deployments, then the teams usually register some follow-ups on that. And that is reflected in an index. And then we can know what kind of maturity different teams have. And there's a lot of different sort of metrics that we track through here. And this is done continuously. And if you haven't sort of done anything on, let's say, the technical debt management, then you might see sort of a peak like you see in this example here. And then you get some notifications on Slack like, hey, we see that you haven't done technical debt management the last X amount of months or something like that. And then you can basically act upon it. Or if you need to redo some assessments that are like in a 12 or 18 month cycle, then you will also get some information about that. And the last thing that the teams have, of course, is access to all of this data. We use Tableau for this at the moment. So there they can go into these different live reports, see how many deployments to production every team in Visma has, how much technical debt is being generated or actually repaid. You can see on this green and red graph. So all of this data is basically available throughout the Visma organization, and everyone can see each other's data. And we can learn from each other, of course. And then, of course, if you want to just look at the SDOP numbers, here is just an example from one team where they can go in and see, like, yes, the delivery lead time is like 1,847 minutes. They have deployed 73 times in average per month throughout the last year. The change failure rate is 3.4%. Yeah, perhaps that's going up, going down. They can sort of look at these different graphs. And then you have all the data that you have in the bottom part there. And the last thing that I want to sort of share with you is basically this: why do we actually believe and use these metrics? And if you that we are like a highly independent software companies within Visma doing what we are doing, we can also replicate some of this research that we have sort of followed. So you should never follow things blindly. That's at least that's my opinion. So even though I say to you, like, do this, you should not blindly just do it because I've said so. You should basically have a good reason for doing it. And you need to think about it in your own context. So context is like really important in everything that you do. So what we have done in Visma and why we sort of believe in this metric is that we have combined a lot of data that we have, like everything from like product NPS or employee satisfaction scores, some like even Slack usage or technical insights, how many times we deploy to production, how many incidents we have. And we have sort of churned this around with different statistical analysis and machine learning models to actually give us some interesting insights. One of the things that we learned, and we have a whole bunch of learnings from these things, is that frequently deployed products, they grow faster. That is something that we have seen before. If you remember the McKinsey & Company data, with the top 25% quartile, or the top quartile is basically growing revenue 5 times quicker than sort of the bottom 2 quartiles. And in Visma, we have basically replicated the same data with our own sort of deployment, using deployment frequency as sort of a proxy for your engineering performance. So we have seen that the teams that are actually deploying most in Visma, their customer base value is growing 4 times more than those ones that are on the bottom. And what is also really interesting is that those products that did not measure, that were part of this study that we have done, they actually grew even poorer than sort of the ones that were just measuring this. And then you can, of course, think about, okay, like you're just using the software, like the deployment frequency as a proxy, that's not very good. Like, how can you sort of defend that? And we have of course thought about it a bit, but we still think that deployment frequency could be a really good sort of pointer towards your engineering performance, because if you do deployment frequency, like if you have a large deployment frequency, that means that you can frequently adjust and get feedback from your end users. So it means, like, if you deploy 300 times a year, you check in with your customers and users 300 times, you get feedback, you adjust, you do things, and then you continue working. Another reason why deployment frequency matters is that if you are able to deploy smaller chunks, that means also that you are lowering the risk of something going wrong. And if something goes wrong, you are really certain that, okay, I know what I did now. I know why production doesn't work, because actually I updated this flag here, which I shouldn't have. And then this sort of caused and everything to crash. So, and that also means that you probably have a more sort of lightweight process and can deploy with smaller risk. And if you're able to deploy more often, the cost of the change is really low, which means that everyone can just sort of do something, push it to main, and then the delivery pipeline will take care of the rest. Like, you have an automated pipeline, you will get feedback from your automated tests along the way. Fast feedback is something fails, and it feels very frictionless, rather than things that basically might hold you back. For example, if you are deploying on a schedule, or if you have maintenance windows and you know that, yeah, we need to wait until Saturday evening before we can deploy something, or mid Wednesday night, for instance. And this is something that we have done as well in Visma. Like, we couldn't deploy things before like the weekend, and I think everyone agrees that you would rather sort of go out on a party and have some fun with your friends rather than be home and wait for some deployments to happen. And so these are just some of the things that might hold you back. But I won't go too much in detail, because I see that we are running a bit out of time, and I would also like to spend some time for your questions. So just to summarize what we have been talking about, first of all, like, why we did all these changes. It's basically because, like, as mentioned, the world is changing fast. Not only changing fast, it's accelerating. And if you want to accelerate with it, you need to sort of keep up and actually be ready to change when the change needs to happen. And when it comes to, like, what are we done and what metrics have you used, is basically fast feedback. You need to act quickly when you actually get that fast feedback, and you need to continuously evolve. How we have done it is basically through this way of working model that we have created, by enabling teams, by doing continuous delivery and making sure that the teams can do what they need to do when they need to do it, and also utilize the public cloud in order to self-service the delivery teams and give them sort of all the power that they need. And also, if you want to start with this journey, and if you think that this is something that you can do as well, and I'm pretty sure that all of you can do this simple start, is just start tracking your deployment frequency. That could be a really great start. And then, of course, you need to sort of paddle back and see, like, okay, why can we not deploy any quicker? Is it because of the manual test that we need to do? Is it because of the environments, the scheduled deployment sort of slots that we have? There's a number of things that can show you sort of the next steps that you need to take. And I have here that I would like you also to think about the change and consider sort of every change that you have, not as something scary, something that you should fear, but actually you should consider it as an opportunity to learn and grow. And also try to think of it every time you see a change, something you need to change, think of it as a chance, actually. Like, this is a chance to do something new, chance to learn, chance to grow. So with that, I would like to say thank you for listening in. And of course, if you have some questions, or if there are some questions, we will gladly take them now. And feel free to connect with me on LinkedIn if you want to discuss some of these things more, or if you have some input or ideas. So thank you very much.
Hey, Mili, that was great. Thanks for giving the presentation. And we're going to jump into our Q&A with the first question from Daniel, if we're ready to show on the screen. Yep, cool. So Daniel asks, how do you make sure that you're using the latest and greatest tools for your team?
Yeah, that's a good question. There are very few tools that are mandated, sort of in Visma, and very few things that are actually mandated in general. So we don't have like how to say, like a cadence that we say like, yeah, you need to stop using this tool, but you need to switch over to this tool. I think you should consider the tools as something that will help you engineer your services and products, rather than you need to jump on the latest and the greatest all the time. If things work, of course, like you shouldn't sort of change it just for the sake of skipping from Selenium WebDriver to Playwright or to Cypress, because those are the new kids on the block. But I don't think I have sort of any more in-depth answer to that than that. So it's there's no way to ensure that. I don't.
Yeah, sure. Nice. And then we have our next question. This is coming from Pranshu.
Mm-hmm.
How much time does it take for new developers to be trained with the shift left, shift right mentality?
Yeah, and that might be really different from actually team to team. We actually have some teams in Visma that are really great at this. Like the first week that you are employed in this team in Visma, the goal of you as a software engineer is actually to push a change to production within the first week of you being there. So you come, everyone says, welcome, hi, nice to meet you. You go around, eat some cake, meet some people. Then you sit down and actually start working on some production issues. And then by the end of the week, even like midweek or end of the week, you have actually deployed changes to production already. And then you already have sort of starting to like think about, okay, this the way to production is not very far and it's not very difficult. So you already from the first week, you can sort of start getting this. But also by using these different indexes that we have, that I shown, you can always see there, like if there are changes that need to be done, they are sort of highlighted there. So you need to sort of, just go with the flow. And I think the rest of the team as well is also sharing sort of how things are being done. And we also have some like great communities around in Visma, everything from infrastructure engineering to testing to architecture, where basically people are having this like mindset of shifting left, shifting right. And it's a part of this model that I mentioned as well, like this way of working. We have presentations about this for all new employees every quarter. So, and also old employees, if they want to sort of brush up, what does it mean to do this in a continuous way? They can also join that. So,
yeah, nice. Cool. And then we have another question from Daniel.
Mm-hmm.
It's how do you become a chief software quality engineer? It's a unique title. What was the progression of that title?
Very good question. It's a bit of a unique title, yes, I must agree on that. I've been sort of like a test manager, test engineer, senior test engineer, automation engineer. Not like don't know all of my titles in the past, but I think sort of my passion for software engineering in general, it's basically what led to this. So yeah, I think that was just sort of a reflection of my passion and drive to for software quality, basically going forward, that we ended up with this.
Nice. Have you seen anybody else with that title or something similar?
Yeah, I've seen some people with some similar titles, and they are usually doing something similar that I'm doing as well. Like I'm part of this enabling team, basically, who enables all of this that we have been talking about, like this mindset, the DevOps mindset, the continuous delivery aspects, all of these different assessments. So we are like 5 people in this team that are helping hundreds of teams within Visma with all of these different aspects.
Yeah, really cool. And then we have another question from Pranshu. How is an enablement team different from a DevOps team or say like an infra team?
Yeah, that's a good question. Like we do follow to some degree some of the sort of team topology sort of mindset when it comes to the team structure. So even though we don't call them stream-aligned teams or something similar, we do have these service delivery teams. They are basically what you can call like a stream-aligned team. And then the enablement team that we are, like from a software engineering perspective, we are helping on these different assessments. But in addition to that, we also have, for instance, a team that is helping out with different tooling. So instead of you needing to set up sort of your entire delivery pipeline, we already have a set of tools that might help you if you want to use them. And this is like purely like free to use. So you can set up things in TeamCity and use Octopus for orchestration, and that's already sort of set up for you. So if you, as a service delivery team or this enable or like a streamlined team, then you can basically just utilize that and push your changes in production by doing that, and you don't need to sort of think about it or how should you set it up, how should you update it, etc. So we even though perhaps we don't call them like enablement teams or platform teams or something similar, we do have them in some different ways, sort of.
Yeah, really cool. And next we have a question from Daniel. How many times does Visma push code in a month on average?
Yeah, so I think I mentioned that we pushed like last year, it was about 37,000 times. So if you divide that on 12, then there is your answer.
Okay. Cool. And then we have a question from Maurice. How are you separating deployment from release? That is, are you releasing new features as code as shipped to production, or do you hide features behind flags and release on a cadence?
Yeah, a really good question, Maurice. And yeah, we are actually separating deployments from releases. So when we say we have deployed to production, it's not necessarily that change is actually available to all the customers. So it might be that it's, as mentioned here, it's hidden behind the feature flag. And then it might be, we do have different sort of release strategies as well. Someone is using this sort of blue-green deployments, making sure that things work before they sort of release everything to everyone. We have these canary releases that you might use. We're not that into sort of dark releases yet, as we have sort of seen in some companies use. But of course, this is very different from team to team, but we are definitely separating like releases from the deployments itself. So yes.
Yeah, very cool. And then another question from Panshu. Is it showing up on the screen? Yeah. Okay. Do you actively use DORA metrics to keep tabs on how much time, money you're saving through continuous deployment?
Yeah, really cool question.
Yeah.
We actually have not calculated that, but given sort of the data that we have, I can imagine that we could probably calculate something here. Like given of course, let's say this there on the DORA side on the Google Cloud, I think there is like an explanation of how you can actually calculate this. So if you just put in some of the numbers there, we'll probably get some savings.
Yeah.
But we don't do it actively, unfortunately.
Yeah. Okay. Cool. And then we have one more question from Daniel. It says, do you prioritize your production schedule based on the type of service?
Not sure if I sort of understand the question correctly. It will be that sort of if the service is very critical, perhaps we deploy not too many sort of things or not too many times. So if it's not very critical, then you can deploy whenever you want. If that is what you meant with the question, then we actually don't have that. We encourage all teams, no matter how sort of critical or important they are, or what kind of type of services they are. We encourage everyone to actually deploy as soon as they can, actually. And also to mention, it's not a competition to be able to deploy. Like, yeah, I just want to deploy. Because if you sort of read the latest DORA reports from 2022, it's also mentioned that if you don't consider stability, basically how many times your changes are failing, and you just push the production just to game the metrics, you will end up with worse quality. So we need to have a really good balance here. So we say to all the teams that basically you deploy when you need to and when you can deploy. You should ideally deploy one change at a time. Sometimes it's not possible, so teams are sort of adding 2-3 different changes into one deployment. But ideally, we do have many teams that are deploying sort of only one change at a time.
Okay, cool. Mili, I think that was our last question. So thanks so much for joining us today. And guys, thanks everyone for joining. If you have more questions, because we're going to be keeping this video posted on YouTube, for example, and on LinkedIn. If you have any other questions, feel free to write them in the comments, and somebody will get back to you with those answers. And we'll keep a record of all the questions in the chat. Other than that, guys, we are in fact Unleash. We're on GitHub. Check us out if you haven't. Just look up Unleash. If you already know we're there and you love Unleash like we love you guys, please give us a star and make that love public. Everyone here today, and this includes you, Mili, you get a swag store discount. So go to bit.ly/unleash-swag and then put in the code Visma webinar, and you get any t-shirt you want from the store with that code. Pretty cool. What's next? Guys, we're going to have a webinar next month with Docker, and it's going to be focusing on team topologies. Keep your eyes on our social media channels or any other way you keep track with Unleash. We'll let you know more on that coming up very soon. And that's really it. Mili, thanks again for joining. Thanks everyone for being here. And that's a wrap.